Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us today. My name is Sarah Alspaugh, and I will be your webinar host coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar, our topic, electromechanical design for product innovation. And I would like to welcome and introduce our speakers today. With us, we have Nick Dahman and Dave Walker. I'll just tell you a little bit about them and then turn things over to them. Nick has been with Siemens Digital Industry Software for 2 years as Senior Marketing Coordinator in NX for Design Product Marketing. Nick's prior experience includes product marketing for cyber and electronic warfare products within the aerospace and defense industry, as well as holding product leadership responsibilities in the telecom industry. Dave joined Siemens in 2011, having completed over 30 years in the mechanical engineering environment across multiple industries, including consumer electronics, renewable energy, and network infrastructure. He worked in large corporates, SMEs, startups, and consultancy roles for high and low volume products with experience in multiple different CAD systems. As a senior technical software product manager, he is responsible for defining the direction of Siemens NX software focused on electronic integration and the electronic and semiconductor industry. We're very excited to have both of you here with us today. Nick, I'm going to go ahead and pass you the ball and make you presenter here.
Thank you, Sarah. Okay. So thanks again, Sarah, and hello, everyone. Thanks for joining today. We enjoy getting to walk you through the possibilities of innovation with our solutions, and I think you'll find this time really rewarding. Our main goal is to address the questions you might have about your electromechanical design processes or processes that you might not currently have in place. So you'll see the screen here asking you the question of what is the cost of a disconnected electromechanical design process? What we're going to do is we're going to answer that question during this webinar by looking at some of the industry trends, how we have arrived at the state of the industry today, and how our solutions can drive your innovation forward. Again, I want to thank you for taking the time out of your day to learn more about our solutions and how we remove the barriers to innovation. Before we move on and before we get into the details of the presentation, I want to briefly cover the agenda of what we'll be discussing today. So as mentioned, we're going to be going over some of the trends and the industry evolution. You're going to find out how you can use complexity as a competitive advantage. We'll also demonstrate how we can guide you through digital transformation. That's a buzzword that you hear not only in our industry, but throughout the tech industry throughout the world. And then we'll explore how NX will transform your electromechanical design processes. I'll go over one of our customers' success, a smartwatch manufacturer who had great success using NX, our Team Center product, and then Expedition. And then I also want to go over some of our leading technology for user experiences and describe some of the different modes of deployment for your use. So let's go over the industry trends. First of all, the growth in electronics has caused a few trends to emerge. We all know that consumers want to be able to take their electronics anywhere, and they also want to be able to do increasingly more with their devices. This drives smaller products with increased features and functionality. Electronics are really permeating every aspect of what we do in our lives. Just think about the white goods industry. Washing machines used to be just that. Washing machines, just a standard product, not a lot of intricacy built into them. But today, there's washers and dryers that can be controlled by smartphones. There's a lot of different connectivity involved with developing that product. So the complexity has increased just within the white goods industry over time. And then another trend is customer experience, and that's really essential to growth. This doesn't apply to just functionality of a product. It also applies to the aesthetics and the look and feel as well. So how have we gotten here? As mentioned, devices have gotten smarter and smaller. There's higher power density. There's same or more power in a smaller footprint. Smarter devices rely on electronics for our day-to-day life. I think a lot of us probably have smart home devices, and who knows how many different connections that we have going on at home. With connected systems, there's increasing expectations for error-free multi-system interactions, such as mentioned smart home setups and connections. So I want us to kind of look at it from a consumer point of view, put ourselves in our consumer's shoes. I think many of you may be able to recall the Sony Walkman from 30, 35 years ago. At the time, I think we thought that this was a complex piece of technology. We had the orange foam headphones and taking our cassette tapes out of our cars and putting them into a smaller device that we can plug with us everywhere. But now that's evolved, and there's so much complexity that lies within a pair of headphones. So I recently purchased a pair of headphones that have some of these same modes of technology built in. So it's pretty common to see Amazon Alexa or Google built into headphones and different app connections, Bluetooth connectivity. This particular set of headphones even has adaptive sound control. So it realizes if you're in an airport, if you're on a bus, if you're just sitting at home. So that plays into the trend of more complexity and smarter devices. So I also want you to take a look at this smart home device and think about all the complexity that lies within it. You have your voice control functionality, processors, interpretation, Bluetooth and Wi-Fi connectivity. You have to account for speakers, microphones, lighting, and connectivity to other smart devices, on top of a power supply port. So imagine being a designer and trying to cram these features and their associated hardware into a device of this size. There's so much complexity in building around the electronics that go into this device. And in addition, designers must take into account the aesthetics of the device. It's got to look good in a living room, a kitchen, bedroom, etc. So it's not just what lies within, it's also the casing of the device and the tools needed to develop the look and feel of the device as well. So that's where the importance and value of the NX next generation design comes into play. But first, we have to discuss how complexity can be used as a competitive advantage that's going to help navigate you through digital transformation while removing some of your complexities. So there's been an explosion of complexity, and you've been able to see that just in the first few slides. There's shorter technology innovation adoption. It's more difficult to enable collaboration across and through the supply chain. Rework and defects in the manufacturing process contribute to loss of revenue or market share. And today, first mover advantage is so critical to innovation that you don't want to worry about your inefficient processes that can put you behind and put you in a lag situation within the market. Manufacturing environments need to be a closed loop, intelligent, and integrated. And we believe that businesses can and need to use complexity as a competitive advantage. So how do we do that? How do we use complexity as a competitive advantage? We accomplish this really through three components: the comprehensive digital twin, the personalized, adaptable, and modern solutions that we offer, and we also offer a flexible open ecosystem. We're going to be covering these throughout the presentation, but first I want to go over the comprehensive digital twin. So the value of the digital twin is how closely the virtual world meets the physical world. So you can continuously optimize both product design and production activities. You can make decisions in confidence because of the trust you have in your virtual model, the simulation of the model, and the closed loop to the physical world. But what do we mean by that? So it means digitally capturing all of the phases of the product development process. From the ideation phase with a digital product that helps you digitally define, improve your design, and analyze its performance, to the realization phase with digital production to digitalize the manufacturing process of your product and anything used to produce it, and to the utilization phase where you can digitally capture and relate all elements of your product from design to manufacturing to the actual product in use. This helps to ensure that it performs as needed throughout its life cycle. So you produce your product in a digital environment, simulate the performance digitally, as well as getting it to come together to form the holistic digital twin. So Daimler's R&D CIO has stated that 80% of product innovation and differentiation now come from electrical, electronics, and software. So how do you navigate through complexity? I think that's a question that you need to ask yourself and think of your processes currently, how they are, and try to understand what is needed to compete in today's market. So time to market for new products is shortening day to day. Electronics customers require the highest levels of performance, quality, and reliability. Your engineering teams must solve significant design challenges within a distributed design partner supply chain. And electromechanical design teams are under great pressure to meet those demands with high quality products that get to market faster. By using electromechanical design solutions from NX, you'll have prime electromechanical design experience to ultimately drive products and innovation to market faster. So what are some design challenges within this realm? As future devices move towards more autonomy and connectivity, there's going to be a need for more embedded electronics. But as we've mentioned throughout this presentation, there's disjointed mechanical and electronic design system operations that create issues with lost information. There's limited traceability and a lack of visibility into the impact of your design changes. This trend creates new packaging challenges from things like batteries, high voltage wiring, sensors, and more. But with our solutions, designers are able to synchronize data more efficiently and collaborate between domains more effectively on critical design items. This really ensures that design intent is properly implemented and can achieve first pass success, which is going to save you time during your product development process. It's going to help get you to market faster. It's going to save you costs, and it's really going to make your resources that you have at your fingertips more efficient. So this delivers true mechanical and electronics interoperability, which enables shorter development cycles by working concurrently and more efficiently. One of the main benefits is that you can streamline compliance and certification, which we know in this industry is a huge ordeal. By finding and fixing flaws early, this really means fewer design and manufacturing errors, which will help guide you through that compliance and certification process at a faster rate. So the design of electronics really requires digital transformation. We mentioned that products are getting smaller, they're getting smarter, they're more connected, and they're developing intelligence along the way. design complexity is outpacing legacy development where silos and manual processes dominate. So you might have your electronic engineer, your mechanical engineer, test, quality, assembly, all in separate silos, which creates an information sharing issues. So our solutions really help remove those silos so that you're operating at the most efficient way possible. And then visualization helps break down those barriers so that teams can design processes that start integrated and stay integrated. So the impact of digital transformation failure can be significant. We actually partnered with Aberdeen Research on a survey to give you some of these metrics on this screen here. So 53% of companies require additional resources to meet their business objectives for new packages and products. 32% of companies identified poor collaboration as a major factor for missing new product objectives. So think back to those siloed off departments. 21% of companies will experience manufacturing delays due to poor data quality and/or inconsistencies in new package and product designs. And 35% of companies will require multiple ECOs on new package and product designs in order to compensate for digital transformation failure. So these were companies who are not prepared for digital transformation. And I think this is one slide to really take away from this entire presentation. So only Siemens can provide the ideation digital thread that reduces the need for manual intervention, help aid collaboration, and improve transparency across disciplines. It really allows you to break down those barriers between your teams and disciplines to enable concurrent product design, seamlessly integrating electronics, mechanical, simulation, and software into the overall product development workflow. And that'll really help get your products to market quicker with an emphasis on higher quality products. Now I want to turn it over to Dave Walker to walk us through some of the more specific functions of our solutions and present a brief demo of our solution. And he's going to help answer the question of what is the cost of a disconnected electromechanical design process.
Yeah, thanks very much, Nick, and hello, everybody. So how significant is this complexity we've been talking about on the product and time to market? Again, partnered with Aberdeen Group, the research that we've got here tells us that 50% of complex products require at least one additional design iteration to address these kind of issues. That's at least one additional iteration. The cost of that iteration, of course, is dependent on your particular workflow. And nearly 70% of corporations cite this synchronization of data as a significant product design challenge. So when we talk about this smaller, denser, faster mantra of product design, we can see that this magnifies the significance of these numbers. So we need to ensure compatibility prior to manufacturing. Waiting is not an option. We don't want to wait for the prototype to come out and find we have an issue there. So for a quick product launch, the printed circuit board in this case and mechanical components must be right first time. And for that, we need an effective collaboration methodology. If we look at the entire scope of the multi-domain landscape in electronics, we see system design through domain architecture into design and simulation and manufacturing, all encompassed in a managed environment. So if we lay the Siemens portfolio on top of this, what we can see is complete coverage in all of these landscape areas. What I would like to do is to now take a few minutes to focus on a specific area, and that's the collaboration between NX and Expedition, one of the ECAD applications we support and integrate with. So I'll take you through the entire life cycle of a design, from the initial mechanical design that is pushed across to the ECAD domain with electronic placement. Then we'll see a typical design change, and then finally the completion of the design. Starting off in NX with a printed circuit board, electromechanical components, and the mechanical items such as the case, fixings, and so forth. This is pushed across to Expedition, where the entire design is communicated, including the mechanics in the correct location and orientation, where electronic placement can take place and take the mechanics into consideration. The placement is then pushed back to NX. Here the components can be previewed and then placed with the correct location, orientation, and placed from the database, be that in Teamcenter, native, or generated from the Expedition database. Once the placement is complete, we'll look at the design change where we'll move the connector and two components and push this change back to NX for review. Each change can be individually accepted or rejected on a case-by-case basis, or altogether, and in this case we will reject the connector move and push that decision back to Expedition. Here we'll see the connector move was rejected and it moves back to the original position, and now the design iterations are complete. The entire board can be completed by running all the trace routes to complete the design. Once complete, we continue the conversation between the domains, and this is pushed back again to NX, where the entire design is realized and can be used for further downstream processing such as thermal analysis, clearance analysis, and this gives us a seamless single digital thread. If we look at the available feature functions, we'll see some impressive capability, from 3D model exchange between NX and Expedition through to design change management. However, I'd rather leave you with some key differentiators. Next slide, Nick. So we have a robust and error-free collaboration capability, supported by a rich feature set that integrates with all major ECAD applications, and a true incremental conversation between the design domains that gives us our seamless single digital thread.
Thank you, Dave. That was a great explanation and demonstration of what our solutions can do. And now I'd like to go through one of our customer success stories using NX, Teamcenter, and Expedition. So Polar's vision was to design the ultimate wearable sports technology. And they're a company of about 1,300 people based in Finland. And they really are the standard for wearables with world-class athletes. So their challenge was to balance size, weight, ergonomics, functionality, power management, aesthetics, and survivability, all within one device. So in the wearables market, you're dealing with complex electronics such as communications, GPS, motion, and biosensors, while balancing the aesthetics, functionality, size, weight, and power of the device itself. So let's take a deeper look into Polar and look at how they met that challenge head on. So they delivered the product with a holistic digital twin. They removed the barriers between mechanical and electronic design, and they used cross-domain collaboration to really make their processes more efficient. It enabled them to achieve tighter form factors while increasing their performance at the same time. And by eliminating some of those silos and making their processes more efficient, reducing some of that rework, it helped to lower their product cost. So overall, they managed, I think, about 500 components with 72,000 attributes. So that's a lot of complexity that lies within something that goes right on your wrist. So a quote from Polar states that the digital twin was a big opportunity, and that they were able to use the digital twin to replicate their test scenarios And these would have otherwise had to have been done in a physical environment. It dramatically sped up their processes to help get their product to market faster. So in a nutshell, the results were they have better cross-domain collaboration to speed development. They have better management of their product variations. And they also have mass production efficiency, including working with suppliers and partners. So I want to turn it over to the next part of the presentation, which describes some of our key technology that we use to help make you more efficient outside of just the electromechanical design processes that we have. So I think there's a lot of opportunity within NX for not only seasoned users of CAD, but also newer users of CAD with our adaptable, personalized, and modern approach. So we're striving to make our solutions easier for our customers and more personalized. So we have an adaptive user interface that really guides you along and predicts commands while you're using NX. We actually won an AI Iconics award with 95% prediction accuracy within NX. So again, I think if you've hired new CAD users into your company, I think this helps speed up their learning curve. It helps your organization, as far as training goes, which helps gets them into the fire quicker to help design new products and get your products to market faster. I mean, I think it's important to look at it at the bigger picture. So we also have an open, flexible ecosystem. There are many ways that customers adopt our technology, and unlike some of our competition, we don't force our customers down a particular path. We're really flexible with our approach. For larger customers, this seems to be the way they prefer to adopt. We support a cloud-streamed environment where customers can take advantage of vast cloud compute resources available for things like simulation. And then other customers, such as startups, are taking advantage of cloud-native applications, which can be purchased directly through our Siemens store and are managed in the cloud. So Siemens Cloud fits your needs in your digital transformation agenda. We have perpetual or subscription business models. We have on-site or cloud-based deployment models. And then we have a combination of both. You can have on-site perpetual, on-site subscription, cloud-based subscription. There's a lot of business flexibility to meet your changing demands within your company. You can scale up or scale down resources depending on workload and what comes your way in the market. So it's really your way and your pace. Our on-premise solutions are deployed in customers' environments and they're managed locally. Cloud streamed, we have high-performance streaming in any browser on any device. Our cloud-connected products are available for purchase today through our Siemens store, and we have automated deployment and updates for those cloud-connected products. And then we also have managed services. Our experts manage application and infrastructure. So I really want to wrap this up by honing in on removing the barriers to innovation and how our solution helps you achieve that. You'll experience increased efficiency and improved workflows to give you more time to create innovative and disruptive products. It's so important to have that first mover advantage in the technology market today and the consumer products market. I really think that our solutions will help you achieve that. It'll help you achieve decreased time to market with best-in-class features and functionality, and you'll be able to discover and eliminate any errors early on in the design process by gaining a deeper understanding of your products and their behavior. One of the biggest things is improving your team and downstream communication to increase collaboration and reduce your costs. And then our enhanced workflows increase design accuracy to get your product to market right the first time. So I really want to thank you again for attending this webinar today. And I hope you've been able to clearly see how our solutions can fit within your organization, not from just the electromechanical design point of view, but from our adaptive UI or some of our different deployment models. We really appreciate the opportunity to speak to you.
All right. Thank you so much, Dave and Nick, for your presentation. And this officially concludes today's webinar. Thank you so much for joining us, everyone, and have a great day.